Halloween.
No.
I dressed up as a wizard. And I thought somebody would comment on my Facebook page. Nobody did.
I don't have.
Ah.
It's you?
That's me.
Oh.
Oh my.
Oh, did you get candy?
No, I didn't. Not even one.
Why you don't get candy?
And the costume is so cheap. So cheap.
Oh.
This I found in the garden. Yeah. This hat I got in Tesco for €2.
2 euros.
I got this for €5.
Wow.
And then you see this thing here?
Yeah.
It's for when it's raining.
Oh.
Like the raincoat for like €3. You know, the plastic one.
Yeah.
Yeah. So altogether maybe €10.
Oh.
Not bad. I think it's good. Doesn't look like me.
Yeah.
And then this picture in the background is from like Harry Potter or something. Okay.
Yeah.
Right.
Good for you.
Fun.
What's your Christmas hat? Just like Santa.
Sadly, yes. Okay. Here we go.
Time to go home.
Sleep time, I know.
Yes. This morning is very cold.
Very cold this morning.
Yes.
Very cold.
Yes.
I agree.
How I get up? Like
Difficult. Some people didn't get up, like Sophie.
Yeah, I don't know. Sophie didn't. She ignored me.
She ignores you.
Yes.
Mm.
In meeting.
Okay, write this down. So cantilevers and further support.
Terrible.
Much? No. Too much English? Too many?
It's difficult.
Too much English?
Yeah, too much English.
A little. A little. A
No,
little.
last time you say a little, at least
No,
this part is very difficult.
There's like 3 words you need to learn. Yeah. Okay. So
And more formulas.
no more formulas.
And difficult questions at home.
Maybe.
And spend nearly 3 hours, 4 hours, and don't go to sleep.
It's good for you.
No.
It's good.
I don't want to spend too much time on physics homework. I want something I can understand.
I can give you easier questions then.
Yeah, not that easy. A little easy.
A little easier. We'll see what we can do. Okay, so this picture here is a couple. It's a very special type of problem because the two forces, they're equal but in opposite directions, like here and here. And it's a very special type of system. And let me just actually draw it here. So what you have, there's a force this way and there's a force this way. Now will this move up? No, it won't move up.
It will spin.
Yeah, it won't move up or down, it'll spin.
Spin, Mr.
Huh?
Spin.
Spin, yep, yep. So this is clockwise, this is clockwise. This here is d over 2, and this here is d over 2. So
why is it clockwise and anti-clockwise?
It is actually. Anti-clockwise. Anti-clockwise. So the total turning force anti-clockwise would be d over 2 times f plus what? D over 2 times f. So the total turning force is d times f. And the d is the total distance.
It's diameter.
Diameter, yeah.
This one.
Well, it's not really a formula. I'm just showing you. You add the two turning forces together, and you get this simple result.
What is L?
Turning force. You know?
Why turning force can like T?
Because t is time.
Oh.
Yeah. Yeah. Now some people use this for turning force.
Yeah.
No, this tau.
Tau, tau, tau,
Tau. Tau.
tau, tau. What's
tau tau?
The very famous people in Facebook internet.
Tau tau?
No, that's like
Tau?
Justin Bieber.
Oh.
One superstar, but we always say because the superstar has maybe a bad physique, so we just say Tao Tao. Tao Tao. It's nickname.
For who?
One Chinese superstar.
Chinese superstar?
Just like
Pop star?
Yeah, pop star.
Ah.
But
You
just
can-
like
you can
Justin
Google.
Bieber.
Only Chinese songs?
No, and some Korean. Yeah, and so
Any English songs?
No, no,
No.
Which is terrible English.
Terrible English.
Yeah.
Okay, so I don't know this person.
Technically it's the same formula,
Wow.
distance by.
It is the same.
Yeah.
I'm just showing you. You can have a simple formula for this type of problem.
You can Google Tao.
I'll Google Tau Tau later.
Tao. Oh, we have picture for.
No, please, please. I don't want to see a picture of Tau Tau. I'm sure he looks like Chinese Justin Bieber, right?
No, he has voice.
Oh.
我要看
Chinese Justin Bieber.
Tao Tao. 你不要嘴有点表情包。
拜拜
China, strange place. Strange place. All right, continuing.
Yeah, you can use this to send to your friend and just like last time we come to you in the bus.
Yes.
At
Oh yes.
Yes, same.
What does this mean?
Means what? Why you fly? Why you don't fly?
Why you don't fly?
Yeah, means if somebody talk too much or too much like I'm better than you.
Ah,
And
you send them this picture.
Yes.
I understand.
Yes.
I'll remember that. It'll be useful.
Yes.
Okay. So a couple is two equal but opposite forces F that are a distance d apart and cause an object to rotate, or Grace, as you said, see this word rotate means spin.
Rotate.
You mean spin, yeah. The total turning force is F multiplied by D. Can you change, guys, can you change the small d to a big D for diameter? See where I have distance small d? Can you change it to a big D? Because what I'm using here is a big D.
Yeah, maybe displacement.
Huh?
It's straight distance. Big D is mostly for displacement.
No, that's actually S.
Oh yeah.
Yeah. I want to make the point that it's not the same distance from the last lesson. That it's not the distance from the turning point to the force, but it's the distance between the forces. Yeah, between the two F's.
So should I change this small d?
Yeah, that and that small d to big D. Got that? Yeah.
Can I see your picture?
This one.
Okay.
Continue? No. Okay. Yes?
Yes.
Okay. Right. Now, here is the little English. Okay. These, are we looking up? Okay, come on, look up. These are all called cantilevers. This one is a simple cantilever. This one is a braced cantilever. And this one is also a braced cantilever. But the difference is the support is provided by a strut. Here the support is provided by a stay, a string. Okay? So the simple one we don't look at because it is too simple. It's these two that we will study now, the braced cantilever. So a cantilever is a rigid, well, you know what, the definition is quite complicated. Really, what I care about right now is you drawing these three pictures with the names. That's most important right now.
So what's this written on the brace cantilever, the support
Braced cantilever
above that, yeah?
in the middle.
Yeah, yeah,
It's called a compressive strut.
compressive.
Yeah. Really, the adjective compressive is not too important. It's the noun strut that's what's important. Just need you to draw the pictures. Huh? No, that's not necessary. I think this definition is too difficult, the English. There are many difficult words in it. Okay, can I continue? You want to write the definition down? Maybe, Grace and Amanda, there are two words I would like you to learn, at least from the definition, that are important for engineering. You see this word rigid? Do you know what that means? So rigid means like solid. Doesn't break, doesn't move. Rigid means strong. What are you doing? No dictionary. No. So what does rigid mean?
Stronger.
Yeah, it doesn't break, strong. And this other word here, protruding. Protruding means like this. Look, it means sticking out. So here, this is protruding from my hand. Protruding means sticking out, coming out. What, like, let's see, around, like here. This is protruding from the wall. It's like it's coming out from the wall. Or at the back there, that shelf is protruding from the wall because it's coming out.
It should be a 90 and then compulsory.
No, it doesn't have to be 90, no. No. Yeah, like means stick out. Like here, it's coming out. Now actually, if you look at this, which of the three is this one?
First one.
No?
The second one.
Well, I think it's just about the second one because there's a little
Oh, yeah.
brace, little strut here. It's a small one, but there's a strut here. Yeah. So this is an example of a brace cantilever with a strut here. Yeah.
Why is that thing even there?
There used to be a fireplace there. Yeah. Yeah, so that means sort of like yeah, like hang on if you I'm trying to hit something solid. Kind of sounds the same. So they must have built it in with concrete or something. It used to be a fireplace before the heater. Yeah. All right, continue.
Yeah.
Yep. Okay. You okay? Right. What's wrong? Are you sure?
Yeah.
Yes.
How many questions do you have?
I think 1, 2, 2. Happy? Oh my goodness. Right. Write this one down. Yep. The first thing I did, the wheel, the two forces like this. Wait. Couple is the turning force. What's the turning force? So here, what's happening? Did you write it down?
Yes.
Which? Yes or no?
Yes.
Yes. Mhm. You wrote this down? Okay. So what's happening here? It's a steering wheel in a car. Yeah. So there's 5 newtons up here, 5 newtons down here, and the distance is 0.3. So the quick way to calculate the turning force here, you can do this plus this of course, but the quick way to do it from the formula I gave you is just 0.3 multiplied by 5. So that's 1.5 Newton meters. Is the answer.
Too much English and just a little.
Too much English and little maths, or too much maths and little English? Which is better?
Too much English.
Too much
Both
English.
are not good.
Uh-huh. Okay. Next example. Now, too much English and too much maths.
Bye bye. Bye bye.
This is the only example I have left to do. So write this one down and then we'll do it.
And then example one.
Then I will give you time to work on the homework, and I maybe
I need coffee for chemistry.
yes, yes. No money.
A little money, so I buy tea.
Uh, when will your mother come to Ireland?
8 of February.
Oh, soon, soon.
Next week.
Next week.
Yes, I will see my mom.
And will she come to the school?
Of course not.
As she should. I'll send her an email. No?
Do you have break?
I do. In 2 weeks, like you.
2 weeks?
I have the same break as you.
Do you have 2 weeks?
No, no, no.
Only have 1 week.
We have 1 week.
Okay.
In 2 weeks. Your holiday's in 2 weeks, isn't it?
What do you mean in 2 weeks?
Oh my goodness. What do I mean? Your holiday will begin
Yeah.
in 2 weeks. 2 weeks from now.
Oh, okay.
2 weeks in the future. Yes?
Never mind.
Do you know time?
Date.
Yes, date.
Not the time. The time is 9 o'clock. The date, I guess, Monday the 15th of February is the beginning.
15?
Well, if you want, okay, Friday, 5 p.m., the 12th of February. You have class at 4 p.m. on Friday?
Yes.
Then your break will start at 5 p.m. on Friday the 12th.
Oh my god. And in chemistry, can you believe this?
Unbelievable.
Yes, unbelievable. So it's next week and next week.
Next week, Friday. Friday next week.
Then Friday.
Next week,
evening,
5 p.m.
And Saturday, Sunday,
And then Saturday, Sunday,
and
Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday.
Yeah. So it's next week. We still have to have class, full-time class.
Yes.
And next week,
Freak.
and go to see the movie.
我想回家.
Which movie?
Deadpool.
Oh, Deadpool. Nice.
Yeah.
I don't want
10th of the February.
10th of February, you will see Deadpool.
Yeah.
Great.
I don't want to go to see movie with my mom.
No. No.
Ask English movie. My mom will ask, do you understand what they're saying? Can you translate? Oh, why? You can translate for me. Oh, why you don't understand? You should understand. You talk for such a long time.
Yeah, every mother.
Same problem for you?
Every Chinese
And
mother.
Every Chinese mother is like this.
Same with
No,
Sophie.
maybe
Same with
every
Sophie.
Yes.
Asian country's mother
Yes.
don't speak English.
Yes. And
Oh, I see.
and they want their
Child to
look like
understand. Yeah.
look like Europe people.
European, I see. What about for you guys now? Would your parents be good at English? I suppose yours would be
Yeah.
the same level as you, would
Yeah.
they? And what about for you?
Yeah, they're good in English.
Yeah.
But
I mean, would they be the same level as you? If they
some-
took an IELTS test, you know?
I'm not sure. Maybe
Yeah.
a little bit more, more than.
You think so?
Yes,
Yeah.
yes.
Okay. Yeah.
Ah, that sounds good.
Yeah. But your parents, they have no English.
No.
My mom have a little English, and my dad's English is apple banana.
That's it. So when they were in school, they didn't need to learn English.
No.
No.
No,
The
just know the vocabulary.
Just some
my
vocabulary.
father my father learned English and forget everything.
And forget
And
everything.
learn and back to apple and banana.
Okay.
And my mom said because of her job she should learn English now.
Yeah, English is
Because
becoming more important.
last time Australia
Oh yes,
person
Australian.
business
Businessman, yeah.
and speaking my mom just sit at here and waiting for after work and get a copy from in Chinese from someone
Oh, I see.
Chinese and English.
She can come to PFE.
No.
Yes. With
No.
Dennis. Yeah.
No, and
No.
she will kill me.
She'll kill you, alright. Yeah, you don't want to see your mother too much, that's right.
Yes. Even in class.
Yes.
Yes, at home.
She can do physics with us.
She don't
She
like.
can sit right beside you.
She hate physics.
Okay, well then she can do business.
Yeah, she hate business too.
Oh.
She want to stay at home.
Okay,
Like
fine.
me.
Like you, okay.
Like computer game.
Like daughter, like mother.
Yes.
Alright, well have a look at this one now, you've got it?
No.
Oh my goodness, you're so slow. Alright, last one.
And when I come back to China, everyone will ask me, "Are you good at English? You can speak English to me. Blah blah blah. You should know everything.
Yes, everything.
I have an English homework. Can you translate for me?"
Oh, your mother does English homework?
No, not my mom, my friend.
Oh, your friends, they will.
Last time my friend sent her homework with QQ.
QQ, yeah.
And can you translate for me? This is for my test.
So all your friends think you are an expert.
Yes.
Yes.
I'm a master.
Professional.
Yes.
Yes. They are very wrong. Okay. A 40 by 20 centimeter sign of 2 kilograms is hung by a braced cantilever. The stay is 40 centimeters up the wall, and the other end is attached to the end of the cantilever. So, right, let's try and draw this. Okay, so we have our wall. And here we have our 40 centimeter.
40 centimeters by 20 centimeters.
Yeah, now that's the sign. So hang on. Wait, sorry, what's the. Oh no, sorry, that's not it. Now what you have here is the sign is 40 by 20. Yeah, you know, like this is hanging from the wall.
But the stay is 40 centimeters from.
No, the stay is 40 centimeters up the wall, so this is 40 centimeters. And this here.
It's not 40 centimeters from the bottom of the wall.
The stay is 40 centimeters up the wall. I would take it from the hinge.
From.
And the other end is attached to the end of the cantilever. This is 40 and this is 20. And this is 5. How big is it? 2 kilograms. It's my McDonald's sign. Right, and there's a 2G going down. Now let me just draw in faintly here this line of action.
What is this sign, this McDonald's sign? It's math?
Yeah, it's 2 kilograms. It's a big sign. Now, off often the most difficult problem is getting started.
2G is 2 multiply G.
2 multiply G. Okay. How many forces are on the McDonald's sign? Is it 2?
No.
3.
It's 3. But what are the 3?
Goes up,
Tension,
goes
gravity,
up, goes down, and goes out.
Yeah, give me the names, please. Weight. What else?
Tension.
Tension.
Reaction.
And then there's a reaction here.
Why reaction?
Why is it like this? Yeah. Um, so if you think about it like this, if you push this into the wall will push back. But also, this wants to fall down, right? Does it fall down? No. So that means the wall must be helping it stay up also. So these two together, you can just write like this. So for example, if we look here, if I push into the wall like this, there's the reaction only going this way. But if I put my hands, if I lean against the wall like this, okay, the wall is pushing out.
and upwards.
Wait, please, look at me, please. I know I don't look like Toto, but please look at me, okay? So, if I didn't have the wall, and I tried to lean back, I will fall. True? Now, if I lean back here, I don't fall. So there's a force going down, but I don't fall, because the wall is helping me stay up. There's a force going up, reaction up. Also, I don't fall this way. I don't fall outside into the hall. So there's a force pushing that way. So there's a force going up and a force going out. So together, it's like one reaction force at an angle. Now, do you understand that? Yeah? Okay. Back to the picture. Yes?
This is T.
From the rope, from the string, yeah. Now what I'm going to do to make the picture a little bit clearer is I'm going to draw this again, but with the 3 forces. So the first one here, there's an or this way, there's a 2G this way, and then there's a T this way. That's this piece here. In fact, you know what the angle is for the T. Who knows what this angle is?
Which one?
This one. 45. Because of the triangle, it's a 40-40 triangle. I mean, the base and the height are the same. So you know that this is 45. So you can know that this piece here is T cos 45, and this piece here is T sine 45. Now, do you know this angle? No, you don't. So we'll just call it theta for the moment.
But isn't it also 45 because it's...
No, not necessarily. Not necessarily, no. Okay, so first we want to calculate the T, is the first question. Where will I put the turning point in this picture? The left, the middle, or the end?
Left,
You must put it...
Middle.
Right.
left.
We have all 3 answers now, left, middle, right. You must put it at the left. And the reason you must put it on the left, does anybody know?
Because that's where it's connected to the wall.
No, that's not the reason.
That's where it breaks the weakest point.
No, it's nothing to do with that.
Because the reaction force.
Yeah,
Oh, because it's touching.
The
no,
yeah.
No,
Rotational
no,
force.
no. You can put the turning point anywhere.
Because the object is heavy and
No,
rely on
no,
the rotation.
no, no, no,
Because it will turn there.
no. You can put the turning point anywhere. Why do I choose to put it there?
Because
Yeah, but why is it easier?
the outlet can get the plus, not minus.
Do I know the or?
No.
Do I know the theta?
Yeah.
No.
No.
If I put the turning point here, then I don't care about these and I need to only use these ones.
Why?
Because you don't care about the force that goes through the turning point. Because only this one is clockwise, this one anti-clockwise, and this one you don't care. No, don't care. Because it goes through the turning point. It doesn't make it turn.
So what about relation?
Huh?
If you just make X is the turning point.
The reaction force
Yeah.
is not in the formula. Because look, here with the door, when I open the door, this is my turning force. But if my turning force goes through the turning point, it doesn't turn. So the force that goes through the turning point, like the T cos, I don't care about it because it doesn't make it turn. And the or also, like here, I'm trying to open this door and I put the force here. Will the door open?
No.
No, I need to have it at least somewhere here, but not here. It's impossible to make it turn.
So if you make this is
Open.
the turning point, the force just care about the up and down, don't care about other direction.
Yeah, if you make that the turning point, only the up and the down you care about. The left and the right you don't care about. And the or, because the or goes through the turning point, you don't care.
We don't care
Just care about up
Wait,
and down.
let's slow down. You first, then you. Yes, just care about up and down. Yes?
so we don't care about the force going to the turning point?
Correct. Yes.
Every force, no.
Yes, because the distance is zero. Like for example, the distance from the turning point to T sine, how big is that? 40 centimeters.
Yeah.
The distance from the turning point to or, zero. The or is at the turning point. So the distance is zero. Yeah?
What if you knew the reaction force and we didn't
Yeah, if you knew the reaction force.
we make a turning point at that time.
Yeah, if you knew the reaction force, for example, and you didn't know the T or whatever, yeah, you could put the turning point at the other end.
Okay.
This is what's strange about the calculation. The calculation doesn't mind where you actually put the turning point. So in fact, we can put the turning point anywhere, but it's easiest to put it at the left. Yeah? Sometimes, as you said, maybe it'll be better to put it in the middle, or at the right. But for this problem, easier to put at the left.
Because where the quantity is unknown.
Yeah, that's generally the trick here, is you put it at the point where you have the least information. And that way you can cancel it out from the formula. Okay. Is it okay? Yeah. So, how much is the clockwise force here? The clockwise moment. How much is that? The clockwise turning force. What's the distance from here to here? 0.2 2g. What is the distance from here to here? 0.4 t sine 45. So look, now you got the t. (13.87 newtons). That's the t. (0.2). The distance from here to here. that okay, Grace?
Yes.
Yes? Okay, the next part?
Yes.
The next part is, what is the reaction horizontally and what is the reaction vertically? So what I want you to do here is to break this up into a horizontal, I'll call it RX, and a vertical, I'll call it RY. Okay. Now, this time, I'll use the center as the turning point. So let me draw it again. This here is RX. This here, well actually you know what, I don't even need to, but I'll just draw it again anyways. This one here is T cos 45 times cos 45. This one here is 9.81 newtons, and this one here is also 9.81 newtons, and this one here in the middle is 2G. 19.62 newtons. Actually, I don't need to use turning force here. Maybe someone can see for me. Yeah?
How do you get that?
T cos 45.
Okay.
Right, what does RX equal?
Equal to 9.08 1.
Yeah, now why is that?
The rightward force equal.
Yeah, the force to the right must equal the force to the left. And part C, you can say RY plus 9.81 must equal 19.62. So then RY will equal 9.81 again, is it?
So what is that? Second C.
What C? Which this is?
Yeah. How to calculate that?
Force going up equals.
Yeah. Force going up equals force going down.
9.1 and downward is 19.26.
Ah, this one plus this one equals
Yeah.
this one.
Oh, I see.
Yeah. Yeah. And then the last part is, what is the magnitude and direction of the reaction force? So, by coincidence, this one is 45 degrees. Sorry, can I go a bit to the right? So for part D, now before you say anything, it's by coincidence it's 45 degrees, okay? Usually it's at a bigger angle, like 60 or 70 normally. So what you have here is RX is 9.81, RY is 9.81. So together, the total reaction would be square root 9.81 squared plus 9.81 squared. So here you get 13.87 newtons, and this angle is pretty obvious. What's the angle here?
45.
45. So the reaction force is 13.87 newtons at 45 degrees to the sine.
So what does that mean to the sign?
Well, for these problems, it's sometimes usual to measure the angle from the vertical. So I'm making it clear that I'm measuring it from the horizontal.
From horizontal. Okay.
Huh?
13 point. Ah, yes.
Yes?
Yes.
Yes.
This means you're
Pythagoras.
measuring it from horizontal.
Yes.
Yeah,
Yeah,
like that.
yeah.
And not from this vertical thing.
Correct. But there's nothing wrong with measuring from the vertical. You just need to say which you're measuring it from.
Like sine means you're measuring from horizontal.
Oh, sine! The McDonald's sign.
No, this one here, 45.
Yeah.
To the sign.
To the sign.
Yeah.
So, to the McDonald's sign.
Oh, I see.
Yeah, this sign is not plus minus sign. It's McDonald's sign.
Yeah.
To the McDonald's sign. What are you checking, Grace?
Nothing.
Are you QQing? No? Okay, did you write this down? Is it okay? Maybe.
Better than before.
Good. Right.
See you.
Now, there's still 10 minutes left.
I want to buy
I can't let you go, it's too early. There's still 10 minutes left.
at 8.
At 8.
Okay.
Yes. So, why don't you use this time to make sure you understand the English in the questions? So you don't have to spend 3 hours translating it. Okay? Let me just stop the recording. Darth Vader?
Yes.